Welcome, everyone, to our causal language in non-causal designs doctoral research method labs webinar. On behalf of the leadership in the doctoral program, Dr. Dina Acoin and Dr. Miranda Brand, I welcome you to this session. Thank you all so much for being here. Just a reminder, if you have any questions at all during this session, please direct them to your instructor or your RPC because of the context I need in order to answer questions. I will not be able to answer them during a live webinar session because there's so much detail regarding your specific applied research project. Let's go ahead and jump in and get started. Today, we are tackling one of the most common issues that we see in applied research projects across all 5 chapters. Using causal language in designs that cannot support causal claims. And what's so interesting about the doctoral research methods writing lab is we are directly addressing issues during these webinars that we're seeing in ED 840 across multiple students. So it's imperative that you share your aha moments from these webinars with the colleagues in your courses, and that you also take a moment during this session to take screen captures and support others in the program by sharing your realizations during this webinar. Causal language in designs that cannot support causal claims is not just a writing problem. It's a design validity problem. When your language overclaims your evidence, your instructor and RPCs interpret it as a misunderstanding of those research design fundamentals. This evening, we have an hour. And in the first half of this hour, we're going to cover the distinction and reference cards. The second half is going to walk through real case patterns so you can recognize what this looks like in your own work. Please do not hesitate to contact your instructor or your RPC to address any questions that you may have as a result of this presentation. Let's get started. This applies to every single chapter of the applied research project. Take a moment right now to stop and self-assess to see if you see any of these issues in your applied research project. This often starts in chapter 1, believe it or not. This is where you are writing your purpose statement using words like examine the impact of, or determine how X causes Y. Language that implies experimental design, but your actual design may be descriptive or correlational. This mismatch then ripples through chapters 2 through chapter 5 because all of the subsequent chapters should build on chapter 1's framing. The bottom line is this, and this is the rule that I want you to internalize this evening. If your design cannot show cause, and most applied research projects can't, then your language cannot claim it. This evening, I will give you specific tools to catch this and to fix it. By the end of this session, you will be able to do 4 specific things. First, distinguish causal language from non-causal language. These are not interchangeable. They're very different. Each belongs to a specific type of design. Second, you're going to be able to identify where overclaiming appears in your own applied research project. Together, we'll look at case examples so you know exactly what to look for. Third, you're going to apply the 5-point language audit. This is a checklist that you can run on your own draft before you submit anything to your instructor in any of the courses, whether it be 810, 820, 830, or 840. Fourth, you will be able to reframe causal claims by using the quick reference cards that I'm going to give you today. Keep those cards, screenshot them, save them, use them every single time you sit down and write. I want to be really direct with all of you in regards to why this matters so much. It's not just a wording problem, it is a conceptual one. When your instructor or RPC reads X caused Y in a correlational study, they don't think, the student made a typo. They think that the student does not understand what their design can actually show. That interpretation triggers a much deeper review in regards to whether or not you design the research, or excuse me, whether you understand the research design fundamentals. And that can cause an instructor to pause when reviewing your specific chapter. The good news is this is completely fixable. Catching it now before you make a submission is the entire purpose of today's session. If it requires reconceptualization, that conversation should happen with your instructor now, not after your chapter is submitted. And this all being said, I realize that you may be watching this webinar at a specific point in the term where you're thinking to myself, oh gosh, do I have these issues? At any point, I want to encourage you to reach out to your instructor or RPC if you think that this is something you need to discuss with them. Okay, so let's really dig in. I want to start by defining two types of language really clearly. Causal language implies that one thing produces, causes, or drives another. It includes words like caused, led to, resulted in, impact of, effect of, proved. Those are all words that are associated with causal language. Non-causal language, on the other hand, describes relationships, patterns, or themes without claiming direction or mechanism. It includes language such as associated with, related to, a theme emerged, participants described, findings indicate. Here is the critical point. Only experimental designs, true experiments with random assignments and control groups, can support causal claims. That being said, most applied research projects use descriptive, correlational, or qualitative designs. These designs can describe, explore, predict and find associations. They cannot in any way prove cause and effect. This in itself is not a limitation of your study. It's an accurate representation of what your design shows. So choose one and commit to it fully across all chapters. Here is one of those quick references cards that you can take a photo of, you can take a screenshot of. I encourage you to share this with your colleagues in the program. Keep it open every single time you write. Okay. This is the language that gives you the common patterns that occur in a non-causal study. Notice that the qualitative language focuses on exploration and description. Explores, describes, examines, interprets. Quantitative, non-causal language focuses on relationships and prediction, but not direction of cause. So examines the relationship between, predicts. The avoid row is equally important. These words signal causal claims. Caused, led to, resulted in, proved, impact of, effect of. Avoid them unless you are running a true experiment with random design, which most applied research projects aren't. One word really has the tendency to trip up folks: impact. The term impact, I would even do a find on your applied research project for this one. It sounds neutral, but it carries a causal connotation. Replace the word impact with relationship, association, or difference. Use this card every single time you write purpose statement, a research question, a conclusion. And in general, I would do a find and replace throughout your applied research project. If I were a student in this program, that's one thing I would do after viewing this webinar. Now, what I'm going to show you next is what 3 studies that show correct alignment look like across 3 really common applied research designs. And once again, this is coming from the place of ED 840. A lot of you know that I typically teach ED 840, and what I've done to inform these doctoral research methods labs is I've looked at the patterns in ED 840 that are surfacing in student feedback. And that has informed the direction that I'm giving you all during these doctoral research methods writing labs. Okay, so first, let's look at study A. Study A is phenomenological. Notice the language. A theme of emotional exhaustion emerged. It describes what participants experienced. It does not say that burnout causes anything or that anything causes burnout. In relationship to that research question, how do nurses describe burnout at work? Study B is correlational. The language Workload was significantly associated with burnout. The word associated is doing critical work here. It reports a relationship without claiming direction. Study C is using multiple regression. GPA accounted for 23% of variance in retention. This is predictive language, which is appropriate for regression. But notice it does not say that GPA causes retention. It accounts for variance. That is meaningful and an accurate distinction. In all three of these cases, study A, study B, and study C, the design, the research question, and the language are all saying the same thing. This is an example of alignment. The next piece that I have to share with you are the red zone words. Dun, dun, dun. I would, if I were a student in this program, this is another thing I would take a screenshot of. Post it above your desk. Share it with your colleagues in this program. These 6 phrases are your red zone words. If I were you, I would do a find in your applied research project, and I would examine instances in which you are using these words. The word causes only belongs in experimental research. If you see this in a correlational or qualitative study, it needs to go. Next up, led to. Led to implies that one thing happened and produced another thing. That is a causal sequence. Correlational studies cannot show sequences. Next up, resulted in. Same problem. It claims an outcome from a variable. Replace it with was associated with or co-occurred with. Proves. No study proves anything. Research supports, suggests, implies, or proves evidence for. The word proves is never appropriate. Next up, impact of. Yeah, this one's subtle. And this is actually one I catch a lot. It sounds academic, it sounds formal, but it carries a causal connotation. Instead, use relationship between or association between instead. Next up, effect of. Technically, this belongs in experimental language. Effect size in statistics is very different. That's a mathematical term. But if you say something like the effect of X on Y, that statement in itself implies, you guessed it, causation. If you have any of these in your current draft, flag them now. Discuss them with your instructor or RPC and ensure that your study is not experimental, and then make the required changes. Let's look at 3 common causal language errors. These apply in several applied research projects that we have seen come across our desks in ED 840. Pattern A. The survey study that claims to prove cause. The original sentence, data proved stress causes burnout. That's two problems. First, surveys can't prove anything. Second, correlational data cannot establish causation. You can fix this by using the term indicated or associated with. Both are accurate and appropriate for survey data. So if you are using a survey in your applied research project, definitely pay attention to pattern A. Next up, pattern B. This is a phenomenological study where the interview led to something. Interviews are a data collection method. They reveal, surface, or illuminate. They do not lead to outcomes. However, the fix is simple. Use language such as revealed a theme. So if you have a phenomenological study, pattern B was for you. Lastly, on this slide, pattern C, the descriptive study that establishes direction. In this case, it is using resulted in. Descriptive designs describe what exists in a snapshot of time. They cannot tell you what happened first and what produced what. The fix is pretty easy. Add co-occurred in the data. This is honest. Two things were present together. This is all the descriptive data can tell you. Notice that in every single one of these cases, the fix is not about making the finding weaker. It's about making it accurate. And that's one of the things that I frequently see across chapters. Sometimes you could be too bold with your findings, right? Just remember, as they say, you're not trying to solve world hunger. Okay, here is a language rule for you. One rule, and you can apply this at every stage of your writing. It's simple to state. Your language must match what your design can actually show. 4 places to check it. Number 1, your design label. If you say correlational study, every subsequent word about findings must be correlational language. Number 2, your research questions. Your research questions must match your design. A correlational study, for example, asks, is there a relationship between X and Y? Not, does X cause Y? 3, your findings section. Your findings in chapters 4 and chapter 5 must use design appropriate language. And this is most often where these errors occur. You run your analysis correctly, but then the narrative is using causal language. The analysis was right, but the words describing it were wrong. 4, your conclusions. Don't have them exceed what your data can support. Chapter 5 is where overclaiming is most tempting. Like I said, you want to solve world hunger. You've worked hard. You want to say something definitive, but chapter 5 conclusions must stay within your design and data can actually support that language. If any one of these 4 rules break down, you have language misalignment that has to be corrected. Okay, are you ready? I have some more red flags for you. We're going to start off with red flags in qualitative studies. So if you're a qualitative individual, pay attention to this slide. These 6 flags come up regularly in qualitative applied research project submissions. The first one is the most fundamental. Research questions that begin with, does X cause Y? Or, what is the effect of? Qualitative research explores. It does not test hypotheses or establish causation. And furthermore, if you're doing a qualitative study, you should not have any hypotheses. Using proves or demonstrates in your findings section is your next one. Qualitative findings suggest, illuminate, or reveal. They do not prove or demonstrate. Next up, when students write that the interviews led to improved understanding, led to, they're treating the method as a cause of an outcome. Methods surface data. They do not produce outcomes. Next up, claiming statistical significance in a qualitative study signals a category confusion. Qualitative studies use trustworthiness criteria, not p-values. Anytime you're saying statistical significance, you're implying p-values, which is associated with quantitative studies. Next, calling themes variables. That's a language crossover from quantitative thinking. Qualitative studies have themes, categories, and patterns and codes, never variables. Finally, using n equals anything to imply representation misunderstands purposeful sampling. In qualitative research, say 8 interviews, that may be exactly right for saturation, but it's not a representative sample in the same statistical sense. Okay. Next up, quantitative studies. So if you are a quantitative person, this slide is for you. These are 6 flags that we flag in quantitative studies. Stop and assess if you have these in your applied research project, if you have a quantitative design. One of the most common, X caused Y in a correlational study. Correlation shows association, not direction, not causation. Next, using the results prove. This is never appropriate in quantitative research either. Quantitative research supports hypotheses. It does not prove them. The word prove should not appear in any applied research project. Do a find, see if it's there in your own. Next, the intervention resulted in, without a control group, that's a classic pre-post study error. If you measure something before and after a program, but you have no control group, you cannot claim the program resulted in the change. Other factors may explain it. Next up, reporting a correlation coefficient and then writing, this shows X drives Y. correlation is symmetric. It says nothing about direction. So if you are reporting a correlation coefficient or an R value, note that it says nothing about direction. Once again, using the impact of language without experimental design. Same issue as before. This is reserved exclusively for experiments. Lastly, drawing directional conclusions from cross-sectional data. If your data was collected at one point in time, you cannot say what came first. Cross-sectional data describes a snapshot, not a sequence. It's kind of like the chicken and the egg problem. Okay, get ready for the case studies. Here we are with case 1, the correlational causer. I'm trying to make this exciting for you all, folks. This case is one of the most common patterns in applied research project submissions. The student has correctly identified a correlational design and ran the analysis properly. They found that the Pearson R was 0.61, really strong correlation. But then in the writings of the findings, the language shifted to causal claims. They said R equals 0.61, and that proves that fatigue causes burnout. 3 problems in one sentence. First, R values do not prove. It indicates a relationship. Second, causes implies direction and mechanism. Correlation of 0.61 tells you that 2 variables move together. It does not tell you which one came first or whether one produces the other. Third, proves is never the right word in research. Fix is clean and does not diminish the findings at all. It just has to rephrase to compassion fatigue was significantly associated with burnout with an R value that equals 0.61 with P less than 0.01. That sentence accurately represents what the data shows, and it is appropriately hedged. For the purposes of your understanding, what I'm going to do is I wrote that sentence out so I can copy and paste it into the chat so you can see exactly how that is structured, especially with the parentheses at the end of it. Okay, I just dropped that in the chat for all of you. Next up, case 2. Case 2 is the qualitative overclaimer. In this case, this is a phenomenological study with 9 classroom teachers. The case has 3 separate language errors packed into 2 sentences. The research question begins by asking, how does mentoring impact teacher confidence? It uses impact. Impact carries a causal connotation. Phenomenological research explores lived experience. It does not measure impact. In chapter 5, they continued. They wrote, mentoring led to significantly higher confidence. 3 errors in that one. Led to. That implies temporal and causal direction. Phenomenology does not establish sequences. Next up, this is a common term. Do a search for this one. Significantly. Significantly is a statistical term with a very precise technical meaning. Do not use it in qualitative findings. Another term, higher. Higher implies measurement, but phenomenology describes experience, not quantities. To fix the research question, you could modify it to how do teachers describe the role of mentoring in their professional competence? This is an appropriate phenomenological question because it asks for the description of lived experiences. The fix for chapter 5. A theme of growing confidence emerged across participants' accounts of mentoring relationships. That is accurate, qualitative, non-causal language. Notice that the findings are just as meaningful, arguably more meaningful, because it's accurately describing what these 9 teachers actually felt. Are you starting to hear the difference in the language? Are you starting to hear how this language shift gives you more accurate descriptions? Okay, case 3. This is our last case here for this evening. This is the descriptive determinist. This case shows a fundamental misunderstanding of what descriptive research can tell you. In this case, the student had 312 student records. Actually, I should back up and say that differently. The doctoral candidate had 312 student records and found that 68% of cases where engagement was low, GPA was also below 2.0. That is a very real and potentially important finding. But the original language, low engagement resulted in a GPA below 2.0, claims that low engagement came first and produced low GPAs. Cross-sectional administrative records cannot show that sequence. You have a snapshot of both variables, GPA and engagement. At the same moment, you do not know which came first, and you cannot claim that one produced the other. The fix uses the term co-occurred. In 68% of cases, low engagement and low GPA were present together. That's exactly what the data shows. The purpose statement also needs to be fixed. Quote, to determine how low engagement causes poor outcomes sets up the entire study as a causal investigation. But let's go back to the design. It's descriptive. You have to revise the purpose in this case to say something like this: to describe the relationship between engagement and academic outcomes. That accurately frames a descriptive study. Notice my emphasis on the word describe. The descriptive finding is still useful. It tells you that 2 things frequently occur together, which is very valuable for practitioners. The fix in this case does not weaken the study. It makes it honest. Okay, are you ready? Are you ready? Okay, folks, I want to reveal, dun, 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 the 5-point language audit. I would run this on your chapter 1, chapter 3 before every single submission if I were a student in this program. This is your pre-submission checklist. I would actually run it on every chapter, technically. Okay. Check 1. Read your purpose statement aloud. Does it use any of the red zone words, such as cause, impact, effect? Go back to the red zone slide. Does it use any of those? If it does, revise. Check 2. Read each of your research questions. Do the research questions ask a causal question if your design is non-causal? Research questions must match the inferential level of the design. If you have a moment where you think your research questions are causal and your design is not, you absolutely have to contact your instructor and RPC immediately. Technically, your research questions have already been approved. It's not something that you can just change. Okay? Your research questions have to match what we have on file for you. So it's really important that you contact your instructor and your RPC if you think that there is something off with your research questions. Okay? They always have to match what we have on file. Cannot say that enough. Don't just randomly change your research questions. Check 3. Read your methodology chapter. Chapter 3. Does any sentence suggest your design can establish causation? Descriptive, correlational, and qualitative designs cannot. Check 4. Read through chapter 4. Every finding you report, ask yourself this: is my language making a claim that my design cannot support? Use those quick reference cards from today. Next up, read chapter 5. This is, believe it or not, the highest risk chapter for overclaiming. Like I said, folks think they've solved world hunger. Every conclusion must trace back to what the data actually showed. If you fail any of these checks, fix before you submit. Even if you're writing chapter 5 in ED 840, go back and revise chapter 1 if you need to. This is your quality gate. Use this 5-point language audit every time you are submitting a chapter. Next up, here is a quick reference. If you have a qualitative study, screenshot this, share it with colleagues in this program. The top row, your research question. Qualitative research questions start with how, what, or why. They're open and exploratory. They do not ask whether X causes Y. Next up, your purpose language. That is to explore, to describe, to understand, to interpret, not to determine, to measure, or to prove. Your data. Your data is interviews, observations, documents, focus groups. Qualitative data is textual and experiential. Your findings. Your findings language should say things like themes emerged, participants described, analysis revealed. These verbs surface what was in the data. They do not claim that the study produced an effect. Your conclusions. Your language is going to sound like this study suggests, data implied, findings illuminate. Qualitative studies never conclude. They illuminate, surface, and suggest directions for further inquiry. Avoid all of the causal language we have covered today. And just as a special note, The term significantly should not be used because it is a statistical term that is associated with a p-value. Do not use it in qualitative findings. Okay, next up, my quantitative folks. Yes, of course, I have something for you too. Same structure. This slide is just adapted for non-experimental quantitative designs. The research question: is there a relationship between X and Y? Or to what extent does X predict Y? These are correlational and regression question forms. Notice neither one asks, does X cause Y? Purpose statement: to examine the relationship between, or to determine whether a significant difference exists between. These are appropriate forms of correlational and comparative designs. Your data. You're going to have those validated instruments, surveys, administrative records, test scores, non-experimental quantitative data. For your analysis must match your design. And when I say analysis, I'm talking about statistical analysis, folks. Correlational research questions get a Pearson R. Comparative research questions get a t-test or an ANOVA. Predictive research questions get regression. Now, if you're not sure about those statistical tests, YouTube can certainly guide you in terms of how to run that type of analysis. Your findings have to use actual statistical results. So, I want to see R equals 0.53. The p-value less than 0.05. You're going to use language such as was statistically, excuse me. Don't say statistically, don't say, I just made a mistake. Don't do that. Was significantly associated with for correlations. Use predicted or accounted for whatever percent of variance for regression. These are all non-causal. Avoid all those same red zone words and be especially careful with effect of in quantitative work. Effect size is a statistical term, but the effect of X on Y implies causation. Woo! Almost done, folks. We have some key takeaways for you this evening. 3 things I want you to pack in your suitcase and remember as doctoral candidates. Number 1, language reflects design. Every word that you write about in your study is a statement about what your design can show. If the words and the design do not match, you have a problem. Number 2, if you cannot show cause, if your design is descriptive, correlational, or qualitative, then you cannot use causal language anywhere in your applied research project. Not in chapter 1, not in chapter 4, not in chapter 5, not once. Number 3, the language audit is your tool. Run all 5 checks on every chapter before submission. If I were a student in this program, that's what I would be doing. This is how you catch misalignment before misalignment catches you. Next month, the Doctoral Research Methods Lab, featuring yours truly, is going to focus on theoretical framework abandonment. This is a common pattern where students introduce a framework in chapter 1 and then it disappears from the rest of the study. If you have a theoretical or conceptual framework in your applied research project, which you should, attend that session. Your assignment for this month is going to take you about 20 minutes. First up, open your current draft, whichever chapter you're working on, and highlight every single word that could be a causal claim. Use this red zone list as your guide that I provided you this evening. Step 2, run the 5 language audit checks. Write down what you find for each check. Be honest with yourself. Discuss any findings with your instructor or RPC. For every flagged phrase, use those quick reference cards I gave you. Rewrite the sentence using the appropriate language. If you find a mismatch that's too difficult for you to fix on your own, that is a conversation you need to have with your instructor or RPC. They're here to support you. Do not try to work around a fundamental design language mismatch alone. Bring it to your instructor or your RPC. Another thing, if you're genuinely unsure about whether a phrase is causal or not, that uncertainty in itself is valuable. Write it down. Bring it to your instructor or RPC. That's the exact type of question they are here to support you with. A question from one of our colleagues is, will this session be recorded, and can we go back and review this as we go through our projects? Absolutely. This session is recorded. It is available on the Doctoral Research Methods Lab YouTube channel. So all of the sessions that we will be offering in this series will appear there. And the link to the YouTube channel will be sent out at the conclusion of the session when the recording is sent to all of you. Now, you all know I have some recommended resources for you. 3 resources for you to have on hand as you work through this. I personally have on my bookshelf, of course, the Cresswell and Cresswell's Research Design 5th edition text. Chapter 1 is really fundamental because it focuses on research, language, and paradigms. Chapter 8 specifically goes deeper into quantitative language conventions. If you only read one chapter from this book, make it chapter 1 to focus specifically on causal language. The next text that I have in my bookshelf that I would recommend, Fields Discovering Statistics text. If you are doing quantitative work, Field has an excellent discussion on the differences between correlational and experimental inference. It's written really accessibly and it's well worth visiting. I would also recommend, of course, your student handbook. These textbooks I recommend from my current bookshelf. They are not recommended by the program. They are not formal requirements of the program. It's just my personal recommendation that I am giving you. Okay, thank you all so much for being here. The time that you've spent this evening has been so incredibly beneficial for your applied research project. I just know it. If I were a student in this program, I would definitely be attending these sessions. So please spread the word. Tell other colleagues in the program about the Doctoral Research Methods Lab writing series. And I thank you all so much for taking the time to really shine as scholars in the field. Thank you so much, everyone. Good night. See you next month.